So hello everyone. So today we are going to learn about network hardwares. I am Sanskar Datta from SVCE in 5th sem NCC. So there is no generally accepted taxonomy into which all computer networks fit, but two dimensions and stand out as important: transmission technology and scale. There are two types of transmission technology that are in widespread use: broadcast links and point-to-point links. Point-to-point links connect individual pairs of machines to go from source to the destination on a network made up of point-to-point links, short messages called packets. Point-to-point transmissions with exactly one sender and exactly one receiver is sometimes called unicasting. In contrast, on a broadcast network, the communication channel is shared by all the machines on the network. Packets sent by any machine that are received by all the others. An address field within each packet specifies the intended recipient. Upon receiving a packet, a machine checks the address field. If the packet is intended for the receiving machine, that machine processes the packet. If the packet is intended for some other machines, it is just ignored. Wireless network is a common example of a broadcast link, with communication shared over a coverage region that depends on the wireless channel and the transmitting machine. Broadcast systems usually also allow the possibility of addressing a packet to all destinations by using a special code in the address field. When a packet with this code is transmitted, it is received and processed by every machine in the network. This mode of operation is called broadcasting. Some broadcast systems also support transmission to a subset of the machines, which is known as multicasting. An alternative criterion for classifying network is by scale. Distance is important as a classification metric because different technologies are used as different scales. So here you can see the types of networks and the interprocessor distances, and they're located like how they're located according to the interprocessor distance. So for example, 1 meter is square meter and 10 meters of one room, then 100 meters one building. So you can pause it and see. PANs, like personal area networks. So basically what you use in your homes. So let devices communicate over range of a person. A common example is a wireless network that connects a computer with its peripherals. Some companies got together to design a short-range wireless network called Bluetooth to connect these components without wires. In the simplest form, Bluetooth networks use the master-slave paradigm. The system unit is normally master talking to the mouse, keyboard, etc. and as slaves. The master tells the slaves what address to use, when they can broadcast, how long they can transmit, what frequencies they can use, and so on. A completely different kind of PAN is formed when an embedded medical device such as a pacemaker, insulin pump, or hearing aid talks to a user-operated remote control. PANs can also be built with other technologies that communicate over short ranges such as RFID on smart cards and library books. LAN, local area network. A LAN is a privately owned network that operates within and nearby a single building like a home, office, or factory. LANs are widely used to connect personal computers and consumer electronics to let them share resources, example printers, and exchange information. When LANs are used by companies, they are called enterprise networks. Wireless LANs are very popular these days, especially in homes, older office buildings, cafeterias, and other places where it is trouble to install cables. In these systems, every computer has a radio modem and an antenna that it uses to communicate with other computers. In most cases, each computer talks to a device in the ceiling as shown in figure. This device, called an AP access point, a wireless router, or base station, relays packets between the wireless computers and also between them and the internet. Wireless LANs, called IEEE 802.11, popularly known as Wi-Fi, which is become very widespread. Wired LANs, so wired local area networks, use a range of different transmission technologies. Most of them use copper wires, but some use optical fiber. LANs are restricted in size, which means that the worst case transmission time is bounded and known in advance. Knowing these bounds helps with the task of designing network protocols. Typically, wired LANs run at speeds of 100 Mbps to 1 Gbps, have low delay, and make very few errors. Newer LANs can operate up to 10 Gbps compared to wireless network. Wired lines exceed them in all dimensions of performance. It is just easier to send signals over a wire or through a fiber than through the air. So topology of many wired LANs is built from point-to-point links. IEEE, which is Ethernet, is the most common type of wired. In figure you can see shows a simple sample of topology switched to Ethernet. Each computer speaks the Ethernet protocol and connects to a box called switch with a point-to-point link. A switch has multiple ports, each of which can connect to one network. The job of the switch is to relay packets between computers that are attached to it, using the address in each packet to determine which computers to send it to. Now we have to go to the metropolitan area network. The best example of MANs are the cable television networks available in many cities. These systems grew from earlier community antenna systems used in areas with poor over-the-air television reception. In those early systems, a large antenna was placed on top of a nearby hill, and a signal was then piped to the subscribers' houses. Wide area network so spans over a large geographical area of a country or a WWW is a wide area, which we will begin our discussion with wired WANs using the example of a company with branch offices in different cities. In WAN in figure, which we'll see in the next slide, is a network that connects offices in Perth, Melbourne, and Brisbane. Each of these offices contains computers intended for running user, that is application programs. So this is Australia, you can see, and it has Brisbane, Melbourne, and Perth. So the job of the subnet is to carry messages from host to host. So these cities which you can see are Brisbane, Melbourne are the hosts. Just as telephone systems carries from speaker to listeners. In most WANs, the subnet consists of two distinct components: transmission lines and switching elements. Transmission lines move bits between machines. They can be made of copper wires, optical fibers, or even radio links. Switching elements or just switches are specialized computers that connect two or more transmission lines. When data arrive in an incoming line, the switching element must choose an outgoing line on which to forward them. So that is it. We have learned about networking, network hardwares, and computer networks. Thank you.